To get started with Node.js, our first step is to install it. The simplest way to do this is to visit their official website at nodejs.org. On the homepage, we'll spot a big blue button that says Download Node.js. This button will automatically provide a download link tailored to the operating system we're using. While we can opt for specific versions or versions for different operating systems by clicking the respective links, for most of us, simply clicking the main link on the green button works perfectly. So that's exactly what we'll do. We'll click on Download Node.js. This will install version 22.14, which gets updated periodically. The great thing about this link is that it always downloads the latest LTS version. Just to clarify, LTS stands for long-term support, meaning it might not be the absolute latest version, but it is the most stable version with long-term support. By downloading the LTS version, we can be confident that we're set for a good while without needing to switch to another Node.js version anytime soon. Once the installer is downloaded, we'll go ahead and double-click it to begin the setup. We need to accept the license agreement and choose the installation folder. I'll stick with the default option, which is recommended. At this point, we have the option to modify the installation and add or remove specific components. I suggest we avoid making any changes and go with the default selection, so I'll just click Next again. On the subsequent screen, we have the chance to install additional software, including something called Chocolatey. Unless we have a particular reason to use it, most of us probably won't need it, and since it's a substantial download, I'll skip it and click Next. Now, we simply need to click Install, and Node.js will be installed on our computer. Perfect. Now that it's installed, let's ensure everything went smoothly. To do this, we can open the terminal. If we're on Windows, we can right-click the Windows Start menu and choose Terminal. Here, I'll type in Node-V. This command will show us the current version of Node that's running on our system. As we can see, it matches the version we just downloaded from the Node.js website. Next, we'll need a code editor. While we could use something simple like Notepad, to enhance our development experience, it's highly recommended we use a dedicated code editor. I'm going to use Visual Studio Code, which offers excellent support for Node.js development. We can download it from code.visualstudio.com. I already have it installed, so I won't be downloading it again. But downloading from the website is straightforward. Just click Next all the way through, and it will set up Visual Studio Code on our computer. Once we have it installed, let's open the folder where we want to develop our Node.js project, and we can create a new file. This file will, of course, be a JavaScript file, since Node.js utilizes JavaScript. Remember, this doesn't mean it will run in the browser. It will run directly on our computer, which is why we installed Node.js. So I'll name my file app.js. Sticking to tradition, we'll start with Hello World. Just as we do in JavaScript for the browser, we can use console.log. So I'll type in console.log hello world. That's it. Now, if we were using JavaScript in the browser, the output would show in the console tab of the developer tools. Since we're running this on our computer with Node.js, we'll see the output in the terminal we're using to execute the program. Let's head to the integrated terminal inside Visual Studio Code. Here, I'll type Node, followed by the name of my file, which is app.js. We don't even need to include the .js extension. We could just type Node app, and we'll see the result. And there it is, Hello World. We've successfully run our first Node.js program. As we continue developing Node.js applications, it's essential to remember that we won't be creating everything from scratch. Node.js heavily relies on pre-made packages that handle much of the hard work for us. To illustrate this, let's look at an example with a package called OS. As the name suggests, it provides functionality related to the operating system. To import this functionality, we'll use require, followed by the package name in parentheses. Require is a function that returns what's exported from the module, which could be a class, an object, or even a function. We'll need a constant to store what's returned from require, and for simplicity, I'll call this constant OS. It's perfectly acceptable to use the same name for both the constant and the package. Now that we have the OS package, what can we do with it? The OS package reveals a wealth of information about our operating system and its current state. For instance, Instead of printing "Hello World" again, we can log information about the operating system. Let's display the username, which we can do using os.userinfo. The username is nested within the userinfo object. Let's run our program, and instead of "Hello World," we now see the current user's name. We can also extract uptime information about our system. Using os.uptime, we can find out how long the system has been running. When we run the program now, we'll see the username along with the system uptime in seconds. Additionally, we can access the type of operating system, the release version, the total memory available, and the free memory. As I mentioned earlier, this is all standard JavaScript. Everything we're accustomed to doing in browser-based JavaScript applies here as well. For example, let's store all this information in a JavaScript object, which we'll call system data. We'll assign keys for each piece of information we've gathered: name, release, total memory, and free memory. With this object in hand, we'll also log it. Running the program now reveals our username, system uptime in seconds, and our newly created object that contains details about our operating system.